Hello everyone. Today we'll be discussing some key theoretical concepts from the chapter 3D geometry. These would be quite helpful in solving the problems which will be discussed at the end of the chapter. So let's start with the theoretical concepts first.
Yeah, so let's get started with the theory. In the 3D geometry, the most important and most basic formula is the distance formula. You need to remember this distance formula. It is very basic. It is a 10th standard level kid would also know it. Okay, if P x1 y1 z1 and Q x2 y2 z2 are 2 points given, then the distance between the 2 points is given by root of x2 minus x1 whole square plus root of y2 minus y2 minus y1 whole square plus z2 minus z1 whole square, or it can be root of summation x1 minus x2 whole square. So basically distance formula gives us the distance between the 2 points in 3D coordinate system. ये फॉर्मूला हमें डिस्टेंस बताता है दो पॉइंट्स के बीच में जिनके कोऑर्डिनेट्स हमें दिए हुए हैं. Now the coordinates of a centroid of triangle having vertices A, B and C, that is the vertices are A x1 y1 z1, B x2 y2 z2 and C x3 y3 z3. Then the coordinates of centroid G, which always lies inside the triangular lamina, are given by summation xi by 3, summation yi by 3, summation zi by 3, which are nothing but the geometric means. Like all these terms are the arithmetic means of coordinates of vertices. So, and the next point is direction cosines and direction ratios. What are these direction cosines and direction ratios? We will first get acquainted with this. So, direction cosines and direction ratios define the direction of a line of a directed segment. Like say in 3D space, we have any segment, any segment, any vector or anything. So how will we know to which direction the vector is pointing? So direction cosines and direction ratios are used to show the direction of a vector and what is the difference between the two? Actually, direction cosines are directly cos alpha, cos beta, cos gamma, where alpha, beta, gamma are angles made by given line or line parallel to it and passing through origin. So alpha, beta, gamma are three angles which the line or line parallel to the given line passing through the origin makes with x-axis, y-axis and z-axis respectively. So L equal to cos alpha, M equal to cos beta and N equal to cos gamma, these are known as direction cosines of a line. Now we move on to direction ratios. Now, what are direction ratios? The most basic definition of direction ratios is three numbers which are proportional to the direction cosines of a line. That is, we have three numbers proportional to direction cosines, implies A by L equal to B by M equal to C by N are. So for this relation to hold, that is A by L equal to B by M equal to C by N, we must this is holding true only for A, B, C as direction ratios and L, M, N as direction cosines. Now, some points to be remembered are there can be infinitely many direction ratios, because simply a by L equal to b by m equal to c by n equal to say lambda. So lambda can attain any real value, so there are infinitely many possible ways for this. So now other important condition is we must have for a given line L square plus m square plus n square equals 1. That is cos square alpha plus cos square beta plus cos square gamma equal to 1. This can be very easily proved by using vectors and all. Now, third point is a line can have two sets of DCs according to its direction, namely cos alpha, cos beta, cos gamma, and minus cos alpha, minus cos beta, minus cos gamma. But for a given direction, direction cosines are always unique. So now moving on, next point is direction cosines of a line joining 2 points. Now we'll need to find we are given 2 points. These are the 2 points P x1 y1 z1 and Q x2 y2 z2. These are the ends of a line segment. Now we need to find the direction cosines of the line PQ. So what we would do is take the difference of the two coordinates respectively. That would give us the direction ratios, and using direction ratios we would then be able to find out the direction cosines. Now direction ratios are directly the x2 minus x1 comma y2 minus y1 comma z2 minus z1. These are direction ratios. Now to find out direction cosines, we must divide each of the direction ratios by root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. We must divide each of the direction ratios with this term so as to obtain corresponding direction cosines. So direction cosines can be found out to be these, where A, B and C are the direction ratios. So now moving on, we'll now study the projection of a line. So what does a projection of a line concern with? We must here indicate this figure, like we must understand this figure. There are 2 points P and Q with coordinates given as x1 y1 z1 and x2 y2 z2. Now we have another vector, say vector B. So the vector B has corresponding points A and B, like from point A normal is dropped to vector B, and from point Q normal is dropped to vector B to meet the vector B at points A and B. So the projection of line segment PQ on vector B is defined as the length of segment AB. So if P is x1 y1 z1 and Q is x2 y2 z2, then projection and B is Li plus Mj plus Nk. That is the direction of line is defined in terms of its direction cosines. Remember, it is direction cosines, not direction ratios, because for direction ratios, as there are infinitely many direction ratios, so there should be infinitely many projections possible, which is actually not the case. So direction ratios, we'll have to consider this. In this given figure, this is line segment PQ, and this is the projection of PQ. Say this is Q dash. So projection is PQ dash, where theta is this angle, which is PQ. PQ cos theta is PQ dash. So PQ dash equal to summation x2 minus x1 whole square power 1 by 2 into cos theta. Now we know the formula for cos theta as L summation L into x2 minus x1 upon root summation L square root summation x2 minus x1 whole square. So this term gets cancelled out with this, and as summation L square is 1, this would give this formula directly. So this formula can directly be obtained then. This is an important formula we need to remember. Now, we must note here that for x-axis we have L equal to 1 and M and N as 0. So projection of PQ on x-axis is this, which is x2 minus x1, simply x2 minus x1. Similarly, we can find out the others. So projection of line joining 2 points x1 y1 z1 and x2 y2 z2 along x-axis would be x2 minus x1, along y would be y2 minus y1, and along z would be z2 minus z1. So now another point to be remembered is if A, B and C are the projections of a line segment on coordinate axis, then length of line segment is root of A square plus B square plus C square. That is, sorry for the mistake here, it's actually A square plus B square plus C square. So ABC are projections of line segment, that is A is x2 minus x1 we saw just now, B is y2 minus y1 and C is z2 minus z1. So अभी हमारी लेंथ हो जाएगी लाइन सेगमेंट की a square plus b square plus c square, which is root of summation x2 minus x1 whole square, which is simply the distance formula. Now another thing to be remembered here is if ABC are projections of a line segment on coordinate axis, that is if there are coordinate axes and ABC is a projection of a line segment on coordinate axis, then direction cosines are given by A by root of A square plus B square plus C square, comma B by root of A square plus B square plus C square, comma C by root of A square plus B square plus C square. Similarly, by multiplying -1 to all the three terms, another set of direction cosines can be obtained for the given line. Now, the next important point in 3D is finding the perpendicular distance of a point from a line or a plane. So, how would we do it? If say there is a point P, x, y, z, and there is a line given by x minus a by x1, and there is a line on which a point is there, a, b and c. Now we clearly know by Pythagoras theorem that Pn equals ap square minus an square whole power 1 by 2. Now ap, p, here AP is the distance of line segment AP, which is given by x minus a whole square plus y minus b whole square plus z minus c whole square, this power 1 by 2. Okay, so AP is given, AN equal to, AN is the projection of AP on line. So perpendicular distance would then be root of AP square minus AN square. That is, and AN is L into x minus a, which is given. That is, AN would be directly the projection of AP on the line. As the line has direction cosines L, M and N, and the line segment AP has direction ratios x minus a, y minus b, z minus c. So length of AN directly comes out as AN equal to L into x minus a plus m into y minus b plus n into z minus c. हमारे पास 3 पॉइंट्स हैं. हमको ये लेंथ, ये वाली लेंथ प्रोजेक्शन से मिली है, हमें ये वाली लेंथ डिस्टेंस फॉर्मूला से मिली है, तो हमें ये वाली लेंथ पाइथागोरस थ्योरम से मिल जाएगी. सो नेक्स्ट वी हैव एंगल बिटवीन टू लाइंस. इफ theta is the angle between two lines, then cos theta is given by L1 L2 plus M1 M2 plus N1 N2, where L1 L2, M1 M2, N1 N2 are the direction cosines of the two lines A and B. Now, if direction ratios are given, then what to do? Then cos theta is defined by A1 A2 plus B1 B2 plus C1 C2 upon root of summation A1 square, which is this one, into root of summation A2 square, which is this term. Now moving on, what is condition of parallelism? Two lines are said to be parallel if we have there are terms like the direction parallel. So one vector should be lambda times other. So this would give L1 by L2 equal to M1 by M2 equal to N1 by N2, or similarly in terms of direction ratio. Now condition of perpendicularity, this is more important as most of the questions are based on it. Now, two lines are said to be perpendicular if theta equal to 90 degree. From the above formula, we have cos theta here would be 0 degree. 0. So, we'll get L1 L2 summation to be 0. This is the condition of perpendicularity. Or it may even be expressed in terms of direction ratios, which is summation A1 A2 equal to 0, or this is an interesting formula, as sin theta is root of 1 minus cos square theta, then sin theta would then be, in case of perpendicular lines, sin theta would be plus minus root of summation L1 M2 minus L2 M1 whole square. This is an important formula which can be easily derived from what we have done till now.